Hello Earthlings, welcome yet again to CPDict. In this video we are going to see the third problem from today's LeetCode weekly contest 204, and it is called minimum number of days to disconnect island. Yeah, we have been given a grid. We have if we have a one in any particular cell, it represents there is a land there, and if there is 0 in any cell, it represents that it contains water cell. It is water basically. So if we have a group of connected ones horizontally and vertically, that is, we are not considering the diagonally adjacent ones, then a group of horizontally and vertically connected ones is termed as one island, and we need to do some processing such that we do not have one island after our whatever we need to do. So yes, so if we see here, it has only one island. We have 4 ones connected with each other. So if we delete these 2 diagonal ones, then these ones are not connected, as we only care about the horizontal or vertically connectivity. And if you see this example, if we delete this one right here, then it will disconnect the whole island, and we will have 2 islands. Okay, and if you see here, we need to delete these 2 ones in the middle. If you are able to see at this one and this one, if we delete these 2, then we would be having 2 islands. And in this case, we do not need to delete any land cell, as before the given input grid itself contains more than one island. Okay, so let's see what we can do to solve this problem. Now as I just wanted to complete this problem or submit this problem during my contest, I came up with a brute force approach. By brute force, well, if you see here, the maximum length of rows and columns of grid is 30. So let's say number of rows are m and number of columns are n, then m into n is just 900, which is, let's say, it is equivalent to 1000. So I came up with a solution whose time complexity is whole square of mn. So it is less than 10 to the power 6. So yes, in future when we come up with more efficient solution, we will surely either share it in the description box or come up with a new video. So just to submit this problem during the contest, I came up with this solution. Let's see this now. So for this, first of all, I created my own dfs function, which starts with anyone, and it visits all the ones of one particular island. It kind of marks them, and I can call this dfs function on any one of my island. Suppose I have a island this right here. So if I call my dfs function on any of these ones, after the complete execution of my dfs function, I'll be sure that I marked all these ones, so in one dfs calls. So in a way, if I do, and then after this one, I'm only doing my dfs function on any one which is unmarked after that. So in a way, one dfs function marks the ones of one island. So the number of dfs function I would be making would be equal to number of islands in my grid, as in one of my dfs function call, it will visit all the ones of one island. So if I am doing m number of dfs function calls, then it also means there are m islands in my grid. Okay, now the first thing I would be doing, first of all, without doing anything, I'll be finding the number of islands which are present in the grid, the input grid itself. So if the number of islands initially is greater than 1, then I do not need to do anything. I will simply return 0, because it is even at this point it is disconnected. I do not need to disconnect it any further. Okay, now and again after that, if I see, I am also during my DFS function call I am also counting the number of ones in my grid. So if I see the number of ones is equal to 1, here there is only one island. No, if I have reached to this point, it means I am having only one island. Okay, so I am done with this part. Even for if number of islands is equal to 0, I'll simply return 0 as this grid is disconnected. So at this point we can only we have come to the situation or scenario where we are having only one island in our grid. Okay, so I see the number of ones. I'm also counting the number of ones in my grid. If I see the number of ones is equal to 1, then I need to delete it, and then I'll reduce my number of islands to 0. Then the answer would be 1. If the number of ones is equal to 2, then it only means the islands are connected, the ones are connected in this way or in this way. So in this case I need to delete both of them, because even if I delete one cell from here, it is still one island, it is not disconnected. So in this case the answer would be 2. Now this is for one case. Now I have covered another case. Suppose if m is equal to 1 or n equal to 1, that is if we are having one row or one column, then I'm seeing if I'm having more than two ones, if I'm having more than two ones and there is one row or one column, then it can only be like this. Then I just need to delete one cell in between except the endpoints. I just need to delete one cell. It can be any cell except the endpoints of this row or column. Then I would be assured that would be having more than one island. So in this case the answer would be 1. Now let's proceed further. Now there's one thing I observed during the contest is the answer in this case can only be 0, 1 or 2. If you see, even if the cells are connected in this way, we just need to delete these two cells, then it will get disconnected. And if the cells are connected in this way, then we just need to delete this cell. So either we would be having this case, and also there is another case which was there in the example as well, this one right here. If we are having two bridges, you can say these ones are similar to bridges which we have in graphs, then we need to delete these two ones. Yeah, you can come up with any other example. You will see that answer can only be any one of these three values. Okay, so there can be multiple examples as well. At this point I think I won't be able to come up with a proof, but if you come up with examples, yeah, this would be the case. Yeah, even let's see another case. If I'm having this array, this grid, then what I can do, I can simply delete this cell. I can just delete this cell right here, and I will be sure that it is having more than one islands. Now I use this information. Okay, I use this information to proceed further. Yep. So let's see what I did. As I have explained earlier, my DFS function runs once for one particular island. That is, so number of DFS functions calls is equal to number of islands. So then what I did was, for each of the cell which is having value is equal to 1, so I traverse the whole grid which takes m into m time. I traverse the whole grid, and I saw that if it is 1, then I changed its value to 0, and then I performed my DFS function on the whole grid, and I checked the number of islands I would be having if I delete this one. I saw if at this point I was having number of islands greater than 1, then it also means if I delete this one, then it will do the trick for this question. Then the answer would be 1. And I would be doing this for all the ones present in my grid. And suppose if I'm not able to get number of islands more than 1, still the number of islands is 1, then I will again change this cell's value to 1 from 0. Like initially I changed its value from 1 to 0. I checked whether after deleting this cell, after deleting this land, would I be having more than one island. If I see that I'm having more than one island, I will simply return 1 as the answer. But if I see still the number of islands is 1, then I will change its value back to 1 again, and then I move on to other cells. I would be doing this for all the ones. And if at any one I see the number of islands in the more than 1, I return 1. And if at the end I have traversed my whole grid and I'm not able to find any such one, it means then my answer would be 2. Because for after deleting any such one, I'm not able to disconnect the graph or disconnect the islands, then it means I must delete two land cells to disconnect my grid. Okay, so that was my approach. The time complexity of this approach would be m into n whole square. As I am traversing the whole grid, it has m into n elements, and my DFS function call takes time m into n at max. So if I multiply this, it would be m into n whole square of n into n. As the value of MNR is less than equal to 30, this will work as far as the summation is concerned. Let's see the code now. Yep, first I've taken this visited array. It simply tells me whether I've visited that particular cell or not. This is the number of islands I would be having after my DFS call. This is the number of ones in my grid, and MN, MNN are the rows and columns. So initially I have marked it as false, all the land cells, as I have not visited them. Now I found out the number of islands in my grid. For each of the ones which has not been visited yet, I called my DFS function, and as I've explained it earlier, it means I have this one DFS function call represents one whole island. So I'm incrementing the island variable. And also if grid is equal to 1, I'm also counting ones, which I will be using later. If I see the number of islands in the grid initially is not equal to 1, I can simply return 0. Even if it was 0, then the answer would be 0, and if it was greater than 1, the answer would be 0 in that case as well. Then I see if number of rows is 1, or number of columns is 1, or we are having number of ones less than equal to 2. Then the answer is, if we are having 2 ones, at this point we are sure that number of islands is equal to 1. Okay, so we are only taking care of this case now, because we have covered all the other cases above. Now if number of ones is equal to 2, then there is no way we can delete one cell and we would be able to disconnect the islands. The answer would be 2 in that case, otherwise the answer is 1. And now the second thing which I was explaining earlier, for each of the grid cell, if it is 1, I am deleting it. First of all, I am storing its index. Now I am changing its value to 0. It is equivalent to deleting that land cell, and then I marked all my grid cells as unvisited and islands at 0. I initialized it islands 0, and then I found out the number of islands I would be having if I delete this particular land cell. And at this point, if I see, yep, I was able to disconnect the islands, as islands is equal to 2, then I simply return 1 here. Okay, and after that, if I see that still the number of islands. Yep, I think it should be greater than 1, as I think even after if I delete one particular land cell, can I have more than 2 islands if I am deleting one particular cell? Yeah, I suppose we can have that scenario. Let's see the example here. Suppose we are deleting this particular cell, and yep, the island is something like this. So if I delete this, then at the end we would be having 3 islands. Yep. So our should be islands greater than 1, and we return 1 here as we are able to disconnect the islands. Otherwise we see that the islands is still 1, then we change its value back to 1, and we move on with other land cells. We check the other land cells, and even if after all this checking of all the ones present in our grid, we see we are not able to disconnect the graph, we simply return 2, as 2 is the maximum answer we can have in this case. Okay, yep, I like this problem, and as I've told initially, when we come up with a better approach and an efficient one, we'll surely share it with you guys either in the description box, or we'll come up with a new video. So I hope you liked the video, and please do subscribe to our channel, as around 85% of our viewers are not subscribed to our channel. So yeah, take care and sayonara.